Hello everyone, this video will cover notes from section 5.3, which deals with factoring polynomials. Now we're asked to factor each of these following expressions. The first one being 24m squared n cubed minus 36m cubed n squared. Now, when you're factoring these two polynomials, we want to look for what's called a GCF, or the greatest common factor. We want to find the biggest number that we can divide into 24 and 36. And in this case, the largest number we can divide into 24 and 36 is 12. So we're going to factor out 12 from 24 and 36. When we factor 12 from 24, we get 2. So 2 we place in parentheses. That represents our first term. When we factor 12 from our second term, the minus 36, we get minus 3. We get 3, and we write that 3 in parentheses. Now we can find the GCF of variables as well. We have 24m squared, that's 2 m's for the first term, and then minus 36m cubed, that's 3 m's for the second term. What's the largest number of m's, the variable m, that we can take from both terms? We can take 2 m's from the first term and 2 m's from the second term. We can't take 3 m's because that first term only has 2. So the largest number of m terms that we can factor would be m squared. So we factor out 2 of our m's, and when we factor m squared from our first term, it cancels out. When we factor m squared from our second term, right, we took away 2, but that leaves 1 left over. So that 1m we write in parentheses next to the 3. Now our n terms. We have n cubed, or 3 n terms, and n squared, 2 n terms. What's the largest number of n's that we can factor? That will be n to the second power, or 2 n's. We factor n squared from n cubed, we'll have 1 left over. That n that's left over, we write in parentheses next to the 2. That represents what's left over when we factor from our first term, minus what's left over when we factor from the second term. We factored out n squared, so those cancel out. So this will be our answer. We have 12m squared n squared outside parentheses, and in parentheses 2n minus 3m. Now look at the next example. We have minus 8z to the 5th power minus 24z to the 4th power. The largest number that we can factor from negative 8 and negative 24 is negative 8. So we factor negative 8 from the first term, that cancels, so we no longer have an integer represented by the first term because we factored out negative 8. And then negative 8, when we factor from negative 24, we'll get positive 3. Our z term, we can factor z to the 4th power from our first term and our second term. Z to the 4th power, when we factor from the first term, we get 1z, z by itself, left over. And when we factor z to the 4th from the second term, that cancels out. So our answer would be negative 8z to the 4th power times z plus 3. All right, now we have 2 other expressions. The first one, 5 times x minus 1 minus 2x times x minus 1. Now we're going to simplify here because this is already factored for us, and we need to figure out how to write our solutions based on these factors. Our first factor of the solution will come from what's shared between both terms. So this example is already factored for us. Look and see how both of these terms have x minus 1 in parentheses. That x minus 1 is going to be a part of our solution. So we'll copy down that shared factor of x minus 1. The second part of our solution will come from the terms that are outside the parentheses. We have 5 outside of the parentheses, and that first x minus 1 will put 5 in parentheses. And then we have minus 2x outside the second set of parentheses, so we'll put minus 2x. This is our solution. So it's the shared factor, x minus 1, and then the factors that are outside parentheses, 5 minus 2x. Now this strategy helps us to understand how to write our solutions when we factor by grouping. In this next example, we're going to factor by grouping. Now the only time you can factor polynomials by grouping is when you have 4 terms. And what you do first is you combine the first 2 terms. So we have combined the first 2 terms, and we combine the second 2 terms. So we make 2 groups. In each of these groups, we're going to find the GCF. We want to find the greatest common factor between each group. In our first group, we have 4x cubed plus 3x squared. What is the greatest common factor? The number or term that we can factor, divide from both of these terms is x squared. We can factor x squared from 4x cubed. We'll get 4x. We write the 4x in parentheses that's left. When we factor x squared from 3x squared, the x squareds cancel, we'll get 3. We write the 3 in parentheses. So we found our GCF for the first 2 terms or the first group. Now we're going to find the GCF of the second group. So 8x plus 6, our factor that we can divide from both of these terms is 2. We factor 2 from 8x, we'll get 4x in parentheses. And when we factor 2 from 6, we'll get 3 in parentheses. Now you know you factored correctly by grouping if you see the same terms in parentheses. They have to have the same sign as well. So that shared factor, the 4x plus 3, that will be a part of our solution. That's the first factor of our solution, 4x plus 3. And now the second factor of our solution will be the terms that are outside the parentheses, x squared plus 2. So here's our solution, 4x plus 3 and x plus 2. All right, in the next example, we're going to factor by grouping again. So we group together our first 2 terms and our last 2 terms. And from the first 2 terms, we're factoring our GCF. So among 6x cubed minus 15x squared, we can factor 3x squared from both of these terms. When we factor 3x squared from 6x cubed, we'll get 2x in parentheses. And when we factor 3x squared from minus 15x squared, we'll get minus 5 in parentheses. Now our GCF among the second group, or the second 2 terms, we get minus 4x plus 10. That GCF is minus 2. So we factor minus 2 from minus 4x, we'll get 2x in parentheses. And when we factor minus 2 from 10, we'll get minus 5 in parentheses. We have a shared factor of 2x plus, or 2x minus 5. That's a part of our solution. So our first factor of the solution, 2x minus 5. And then the second factor, the terms that are outside parentheses, 3x squared minus 2. This is our solution, 2x minus 5 and 3x minus 2. All right, another example of grouping, we have variables ax plus bx minus ay minus by. So we group together the first 2 terms and the last 2 terms. And from that first set of terms, ax plus bx, we can factor x from both of those terms. What's left after we factor x? From ax, we get a in parentheses. And when we factor x from bx, we'll get b in parentheses. Minus our second 2 terms, we can factor y. So when we factor minus y, from minus ay, we get a in parentheses. And when we factor minus y from negative by, we get b in parentheses. See our shared factor of a plus b, that's a part of our solution. And then the next factor will be the terms that are outside parentheses, x and minus y. This is our solution, a plus b and x minus y. Okay, the next example, we're solving for x. Now we can solve for x by factoring. So we find that GCF, ax plus bx equals c. On this left side of the equation, we're going to factor that GCF of x. When we factor x from ax, we get a in parentheses. And when we factor x from bx, we get b in parentheses equals c. Now we're going to solve this equation for x. We'll divide both sides of this equation by a plus b. The a plus b's will cancel on the left side of the equation, leaving x. We carry down our x. And on the right side, we have c divided by a plus b. This is our solution. X equals c divided by a plus b. And the next example, you're solving for y. So we have ay minus de equals by. Now notice these two y terms are on opposite sides of the equal sign. So we need to carry the by to the left so that we can combine those like terms. We're going to subtract by from both sides of this equation. Subtract by from both sides of this equation. Also, we're going to remove that DE term. So we're going to add DE, move DE to the right side of the equation. So we're adding DE to both sides. When we do that, the DE's will cancel on the left side of the equation, and that leaves AY minus BY. On the right side, the BY's will cancel, leaving DE. Now we're going to take our GCF, factor y from both terms on the left side of that equation. When we factor y from AY, we get A in parentheses. And when we factor y from minus by, we get minus b in parentheses, equals DE. Now remember, we're solving for y, so we're going to divide both sides of this equation by a minus b. The a minus b's will cancel on the left side, leaving y, and then our solution, y equals DE divided by a minus b. All right, now we're solving this equation. It says a plus b, or a times b times c. A, b, c means we're multiplying all three of these variables together. A times b times c equals 0. So when we solve this equation, that means that either of these variables, either a or b or c, could be equal to 0. We don't know which one is, but either of those could be equal to 0. We know that when we multiply 0 times any number, we get 0. And because we don't know which of these variables is 0, we would solve it as a equals 0, or b could be the one that equals 0, or possibly c equals 0. And you set both of those equations, or both of those variables, or all three of those variables equal to 0. In the next example, you can see this a little bit clearer. We have 4x outside parentheses, and then 3x minus 7 equals 0. To solve, again, we don't know which of these terms equals 0. So we're going to set each of them equal to 0. 4x, the terms outside parentheses, could be equal to 0. Or 3x minus 7 could be equal to 0. After you set both of those terms equal to 0, you'll solve the equations to get your two possible solutions. So 4x equals 0, we solve, divide both sides of this equation by 4. And x equals 0 over 4, or 0. The second expression we wrote as an equation, 3x minus 7 equals 0. To solve, we're going to add 7 to both sides, And then we're going to divide both sides by 3. We'll get x equals 7/3. So our two possible solutions, x could be 0 or 7/3. All right, in this example, we have outside parentheses 7m and inside parentheses 3m plus 1 equals 0. Now, because we don't know which of those terms equals 0, we're going to set them both equal to 0 and solve the equation. 7m equals 0 or 3m plus 1 equals 0. But the term on the left, we're going to divide 7 on both sides of the equation. We'll get m equals 0 divided by 7 or 0. And 3m plus 1 equals 0. We'll solve by subtracting 1 from both sides of this equation and then dividing both sides by 3. The 3's will cancel, leaving n equals negative 1/3. So our two possible solutions, m equals 0 or n equals negative 1/3. In the next problem, we have factors 3x minus 5 and 7x plus 11 equals 0. We'll set both of these factors equal to 0 and solve the equation. So 3x minus 5 equals 0 or 7x plus 11 equals 0. With our equation on the left, we're going to divide both sides by, we're going to add both sides of the equation by 5. We're adding 5, we'll get 3x because the 5's will cancel on the left side, equals 0 plus 5 or 5 on the right side of that equation. And then we're going to divide both sides of the equation by 3. The 3's will cancel on the left side, leaving x equals 5/3. Or on the right side, we're going to subtract 11 from both sides of this equation. 11's will cancel on the left side of the equation. And on the right side, we have 0 minus 11. That gives us negative 11. Then we're going to divide both sides of the equation by 7. The 7's will cancel on the left side, leaving x. And that equals negative 11/7. So our two possible solutions, x could be 5/3 or negative 11/7. All right, in the next example, we have to factor first. So we have 7x squared minus x equals 0. We got to find that GCF. So between 7x squared minus x, we can factor x from both of these terms. When we factor x from 7x squared, we'll get 7x in parentheses. And when we factor x from minus x, we'll get minus 1 in parentheses. Now we're going to set both of these terms equal to 0 and solve the equation. So x outside parentheses could equal 0, or 7x minus 1 equals 0. So x equals 0, that's one of our possible solutions. And the second, we'll add 1 to both sides of the equation on the right side. The 1's will cancel, but carry down our 7x on the left side of the equal sign. And then 0 plus 1 leaves us with 1 on the right side of that equation. Now we're going to divide both sides of this equation by 7. The 7's will cancel on the left side, leaving x equals 1/7. So our two possible solutions, x equals 0 or 1/7. In the next example, we got to factor again. But first, we want to set our equation equal to 0. So we need to subtract 5x from both sides of this equation. That leaves us with 15x squared minus 5x on the left side equals 0. Now we'll find our GCF. What is our greatest common factor? We could factor 5x from both 15x squared and minus 5x. When we factor 5x from 15x squared, we get 3x in parentheses. And when we factor 5x from minus 5x, we get minus 1 in parentheses. Now we'll set both of these factors equal to 0 and solve. So 5x equals 0 or 3x minus 1 equals 0. So with our equation on the left, we're going to divide both sides by 5. We'll get x equals 0 over 5 or 0. And the equation on the right side, 3x minus 1 equals 0, we're going to add 1 to both sides of this equation. The ones will cancel on the left side, leaving 3x. And on the right side, 0 plus 1 gives us 1. Then we're going to divide both sides of the equation by 3. The 3's will cancel on the left side, leaving x, and that equals 1/3. So our two solutions, x equals 0 or x equals 1/3. All right, the next example, we have to carry this 34x squared by subtracting it from both sides. In this problem, we're actually going to do opposite movement. So we have our positive 34x squared, that's positive. We want to carry our x term from the left to the right so we could keep that initial term, that leading coefficient, as a positive number. So we're going to subtract 51x from both sides of this equation first. When we do that, the 51x will cancel on the left side, leaving 0. And on the right side, we'll have 34x squared minus 51x. From there, we want to find our GCF. What is our greatest common factor between 34x squared and 51x? It's 17x. When we factor 17x from 34x squared, we get 2x in parentheses. And when we factor 17x from minus 51x, we get minus 3 in parentheses. Now we're going to set both of these terms equal to 0 and solve the equation. So 17x equals 0 or 2x minus 3 equals 0. With our equation on the left side, we're going to divide both sides by 17. We'll get x equals 0. Or let's add 3 to both sides of the equation on the right. The 3's will cancel on the left, leaving 2x equals 0 plus 3 on the right side, we'll get 3. Next, we're going to divide both sides of this equation by 2. And the 2's are going to cancel on the left side, leaving x equals 3/2. So x equals 0 or 3/2. And then the next example, we have 45x to the 4th power minus 30x cubed equals 0. So our GCF, we got to find the greatest common factor, is 15x cubed. We'll factor 15x cubed from 45x to the 4th power, and that gives us 3x left. We write that in parentheses. And when we factor 15x cubed from minus 30x cubed, we get minus 2 in parentheses, equals 0. Now we're going to set both of these factors equal to 0 and solve the two equations. So we have 15x cubed equals 0. Divide both sides by 15. The 15's will cancel on the left side, leaving x cubed equals 0. And we see x is just 0. Or 3x minus 2 equals 0. We're going to add 2 to both sides of this equation. The 2's will cancel on the left side, leaving 3x equals 2. And then divide both sides of the equation by 3. We'll get x equals 2/3. So x equals 0 or 2/3. Next, we have a word problem. If a golf ball is hit upward, so you hit the ball upward with a velocity of 66 feet per second, that's approximately 45 miles per hour. Its height in feet, so the ball goes up and then it comes to the ground. Its height in feet, so h represents height, above the ground after t seconds can be modeled by this function, h of t equals minus 16t squared plus 66t. Letter A, determine when the ball hits the ground. So when will that height be 0 again? Remember, we have points where the golf ball starts at the beginning on the ground, then it's hit up and it comes back to the ground. So there are 2 points when that ball is going to be on the ground. So we're looking for the value of this function when we get 0 for our height. So h of t is 0. So to do that, we're going to take our function and we're putting 0 for h of t. We're going to solve this function because we need to know what are the t values when h of t is 0. So we take that right side of our function, that negative 16t squared plus 66t, and we're going to remove both our positive to our, well, both of our terms to the opposite side of the equal sign so that we could have a positive number as our leading coefficient. So the very first thing we do is add 16t squared to both sides of the equation and subtract 66t from both sides of the equation. Now when we do that, that 16t is moved to the left, so we have 16t squared, and then that negative 66t is moved to the opposite side. From there, we're going to find our GCF. We need to find the greatest common factor that we can factor from both of these terms. Now, looking at 16t squared and minus 66t, we can factor from both of these terms. From both of these terms, we have 2t that we can factor. When we factor 2t from 16t squared, we get 8t in parentheses. And when we factor 2t from minus 66t, we get minus 33 in parentheses. Now we'll set both of these factors equal to 0 and solve. So 2t equals 0 or 8t minus 33 equals 0. So on the left side, we're going to divide both sides of this equation by 2, and we'll get t equals 0. Or on the right side, we're going to add 33 to both sides of the equation. 33's will cancel on the left, leaving 8t. And on the right side, we have 0 plus 33, that's 33. Then we're going to divide both sides of that equation by 8. The 8's will cancel on the left side, leaving t. And on the right side, we'll get 33 eighths. So t equals 0 or 33 eighths. That's part A. The ball will strike the ground at time point 0 and approximately 33 eighths of a second after it's hit. Part B, how high was the ball after 2 seconds? So using our function that we were given at the beginning, since we have that time point 2, we're going to substitute 2 everywhere we see t. So that becomes h of 2 equals negative 16 times 2 squared plus 66 times 2. And when we simplify, we should get 68 feet. That's the last example from this section. We're going to stop here.